Students, in this video I am going to discuss general form of Abel's singular integral equation. In previous video we have discussed about the specific form of Abel integral equation, but here we are having general form. So what is the general form? So it is given that this f of x is equal to a to x yt divided by hx minus ht. This total numerator power is alpha dt, where alpha is in between 0 to 1. This is the basically the general form. In previous form basically we have taken hx as linear function x. So x, this will be x, then this will be t, so x minus t, but here we are having hx and ht. So this is the only difference. This is more general than the previous case. So here important thing is that ht is strictly monotonically increasing and differentiable function in open interval AB, and h dash t is non-zero. Fine, this is non-zero in open interval AB. Now to solve the above equation, consider the integral this j is from a to x h dash u fu divided by hx minus hu raised to the power 1 minus alpha du. So we are considering this interval. This is equation number 2. Fine. Now from 1, if here just replace x by u, so we get fu a to u yt divided by hu minus ht raised to the power alpha. This is third. So put fu from third in 2. So this fu. So this is substituted from here. So when we substitute, we get j is equal to a to x h dash u, then this hx minus hu raised to the power 1 minus alpha, and now fu is replaced by here. So t a to u yt divided by hu minus ht raised to the power alpha dt du. Fine. So now interchange or change the order. So first find out the limit. So limit is this. Here is this t axis, here is the u axis. So first, what is the limit of t? T is from a to u. A is a constant, so this is a, t is equal to a, and this is t is equal to u. This. Then limit of u, u is a, this u is a, and u is equal to x. X is also considered as a constant, so this is so. This is line u is equal to x. So this triangle is basically the common area. So this is the strips parallel to u axis, this is the strip parallel to t axis. Now apply change of order. So here double integral. First we are integrating with respect to u. Rather than t, we will integrate with respect to u. So that's why this yt will be outside and this h dash u will be inside. So h dash u du divided by this because here u is also involved. So hx minus hu raised to the power 1 minus alpha and hu minus ht raised to the power alpha and then dt. So this is, and now the limit. So first we are taking the limit of u. So what is u? So u is this. Here this is nothing but u is equal to t to the upper limit, which is u is equal to x. So u is equal to t to x. Now limit of t from here, that means t is equal to a lower limit to the upper limit. Upper limit is this corner point. So at this point u is equal to x, so t is equal to also x. So that's why x. So this is number 4. So now we will consider the inner integral as I is t to x h dash u divided by hx minus hu raised to the power 1 minus alpha hu minus ht, that means this du. And now try to solve this integral and then finally substitute it here. So suppose to solve this, first we will try to solve this with the help of beta gamma function, just we have done earlier. So what we will do, we have to convert the range or this limits from t to x as 0 to 1. So that's why we will need the transformation. So this is the transformation. Hx minus hu divided by hx minus ht is equal to s. So from here h of u is equal to h of x minus hx minus ht into s. Now differentiate this. So here this will be h dash u du. In the right hand side, s is the variable, x is just a constant, so this will be 0. So minus this part and ds. So now substitute this here. So what we get, I is equal to integral, then h dash u du, this is nothing but minus of this, so minus this, divided by hx minus hu. So from here hx minus hu is s into this, so hx minus ht raised to the power 1 minus alpha, s raised to the power 1 minus alpha from here. Then hu minus ht, what is hu? Hu is this hx minus this, so hx minus this minus ht raised to the power alpha. Fine. Now the limit, when u is t, so when you put u is equal to t, so hx minus ht, so this will be cancel out, so s will be 1. When you put upper limit x, so hx minus hx, that's 0, so 0. Fine. So now interchange the limits. So s is from 0 to 1, that means you will have a minus sign here, minus is already available, so minus minus becomes plus. So hx minus ht ds divided by hx minus ht raised to the power 1 minus alpha, s raised to the power 1 minus alpha, and now from this bracket take hx minus ht common, so hx minus ht raised to the power alpha, and then we will get 1 minus s raised to the power alpha. So this is the integral. Now apply the beta gamma function. So this is I 0 to 1 s raised to the power alpha minus 1 minus s raised to the power minus alpha ds, because this will be, you will see, this will be cancel out, this and this, total power will be 1, but already available 1 in the numerator part, so they will be cancel out. So only left term will we have s raised to the power alpha minus 1 minus s raised to the power minus alpha ds. Fine. So integral 0 to 1 s raised to the power alpha minus 1 minus alpha, this can be written as 1 minus alpha minus 1 ds. So this is b beta alpha 1 minus alpha beta, and in terms of gamma, its value will be gamma alpha gamma 1 minus alpha divided by gamma alpha plus 1 minus alpha. So gamma alpha into gamma 1 minus alpha, this is nothing but pi upon sine alpha pi. So put this value in equation number 4. So what we will get, j is equal to t from a to x yt pi upon sine alpha pi dt. So we will substitute this value herein. We are putting this value here. So this will be this. So from here, pi upon sine alpha pi integral t to x yt dt is equal to j. But what is j? J is nothing but, so we will substitute the value of j from equation number 2. So j is this, fine. So we will put it here. So now we are writing first right hand part, so this is the right hand part, is equal to j is this, a to x h dash u fu divided by hx minus hu 1 raised to the power 1 minus alpha du. So from here, this take this pi upon sine alpha pi in the right hand side. So a to x yt dt is equal to sine alpha pi upon pi integral a to x h dash u fu divided by hx minus hu 1 minus alpha du. Now differentiating both sides with respect to x and use Leibniz rule. So d by dx integral t is equal to a to x yt dt is equal to sine alpha pi upon pi d by dx a to x h dash u fu divided by hx minus hu raised to the power 1 minus alpha du. Apply Leibniz rule here. So this will be integral t is equal to a to x partial derivative del by del x yt dt plus, now substitute the upper limit here. So y upper limit is x, so yx, and now differentiate upper limit with respect to x, so dx by dx minus substitute the lower limit here. So y at t की जगह a रख देंगे तो y a, and now differentiate lower limit a with respect to x, so dA by dx is equals to right hand side as it is. So now when you differentiate this part, so this will be 0, so 0 plus here we have yx minus this will be 0, this is a constant, that's why, and right hand side as it is, so yx is this. So now replace u by t, replace u by t here. So what we will get? We will get this yt is equal to sine alpha pi upon pi d by dt a to t h dash u fu du divided by ht minus hu raised to the power 1 minus. So this is the solution, general solution of Abel integral equation. Okay, if you will see here, we have limit a to x, but sometimes we are also having another kind of form of Abel integral equation where the limit is, यहाँ lower limit constant है और upper variable है, but sometimes we have another form of singular integral equation जहाँ lower limit variable होती है, upper limit constant. So this is basically another form. So this is the another form. Another form of Abel integral equation is f of x is x to b. लोअर लिमिट इज वेरिएबल, अपर लिमिट इज कांस्टेंट b, बिकॉज इंटरवल जो था हमारा a to b था. सो yt dt डिवाइडेड बाय ht माइनस hx रेज टू द पावर अल्फा, अल्फा इज इन दिस. सो if we take this equation as Abel equation, then the solution will be yt is equal to minus, here is plus, here is minus, sin alpha pi divided by pi d by dt, लिमिट a to t की जगह हो जाएगा t to b h dash u fu डिवाइडेड बाय एच यू माइनस एच टी रेज टू द पावर 1 माइनस अल्फा डी यू. तो यहाँ एच टी माइनस एच यू था, यहाँ है एच यू माइनस एच टी. फाइन. सो दिस विल बी द चेंज एंड फाइनली दिस इज द सॉल्यूशन. आई होप यू अंडरस्टैंड. सो दिस इज Abel in another form of Abel integral equation. Now example number 1. Solve fx is equal to integral a to x yt divided by cos t minus cos x raised to the power half, where 0 is less than equal to a is less than equal to x is less than b is less than pi. Fine. So x is laying in between a and b, and a is greater than 0 and b is less than equal to pi. So now if you compare this with general Abel integral equation, then ht is strictly monotonically increasing function. What is ht? Ht is this, cos t. So what is your ht? Ht is here cos t. So this is strictly monotonically increasing function. Fine. In the range 0 to pi. So rewrite this equation as this, f of x is equal to a to x yt divided by 1 minus cos t minus 1 minus cos t raised to the power half. So now this function, because this is strictly monotonically increasing function, but what is the requirement of h? If you will see, what is the requirement of h? H should be monotonically increasing function, strictly monotonically function h in the interval. So here ht is strictly monotonically function. Fine. So now we will replace, so just add and subtract 1, so we get this. So here rather than taking this h, we are taking this h. ht is 1 minus cos t. Fine. And alpha is half. ठीक. Okay. This is monotonically decreasing. So we are converting basically decreasing function into increasing one. That's why we have to take this transformation. Fine. ये decreasing था, हमने इसको increasing में convert किया है. So that's why 1 को add किया, 1 को subtract किया. Fine. So this is now monotonically increasing function. Monotonically increasing function. ठीक. So then using above solution, yt will be sin pi by t. Use direct this equation. This solution sin pi by 2. So alpha की जगह half रखेंगे यहाँ. So sin pi by 2 divided by d by dt a to t h dash u. So derivative of this function will be sin u fu divided by 1 minus this raised to the power half du. Fine. So sin pi by 2 is 1. So yt 1 by pi d by dt a to t sin u fu divided by this du. So if f is given to you, then you can easily find out the solution. Similarly here, this is the equation. This is the equation, f of x is a to x yt divided by x square minus t square raised to the power alpha dt. Alpha is in between 0 and 1 and x is laying in between a and b. Comparing given integral equation with general Abel integral equation, we get ht is t square. So there is no need, because t square is here, this function is increasing function in this range. That's why this is increasing function and now directly apply this. तो अगर डिक्रीजिंग है तो उसको पहले इंक्रीजिंग में कन्वर्ट करना पड़ेगा, बट अगर डायरेक्टली इंक्रीजिंग है तो देर इज नो नीड टू add or subtract anything. So yt is 2 sin alpha pi divided by this. This is the solution. So this is basically the Abel integral equation. Fine. So this is the Abel integral equation. This is the solution. And now in next video I will discuss Cauchy type singular integral equations. Cauchy type singular integral equations. So we will discuss this part in the next video. Thank you.